Hey guys, Mr. Backerberg here. In this video, we're going to look at the derivative of a cosine function. So here we're going to be proving the derivative of a cosine function. So what we're going to be doing is taking the limit of the cosine of x plus h minus the cosine of x all over h, and we're going to be doing this as h is approaching 0. Now we are going to have to use a trig identity in here. So there's a trig identity that says if we've got the cosine of some u plus v, then what we do is take the cosine of the u value times the cosine of the v value minus the sine of the u value times the sine of the v value. So we're going to take that and apply that to this cosine of x plus h. So we do the cosine of x times the cosine of h minus the sine of x times the sine of h, and then we still have this minus cosine of x hanging out on the back end, and this is all still being divided by h. I'm going to rearrange the numerator just a little bit. I see that we have this term with the cosine of x in the front, and then I see another cosine of x on the back end. So we're going to rearrange that so that those pieces are closer together so that we can do a little factoring with this. So this is going to say the cosine of x times the cosine of h. Then I'm going to do the minus cosine of x, and then I'm going to put the minus sine of x times the sine of h, and this is all still over our h value. Now with these cosine of x's, we're actually going to factor out the cosine of x. So this is going to say the cosine of x times the cosine of h minus 1 minus the sine of x times the sine of h, and again this is all still over h. I'm going to unadd these fractions. So I'm going to split these numerators up into two separate fractions, and each one of them is going to get a copy of that h denominator. So this is going to be the cosine of x times the cosine of h minus 1 all over h, and then minus the sine of x times the sine of h all over h. Now what I'm going to do with these fractions is there's multiplication happening on top that I'm going to split up a little bit. So I'm going to pull this cosine of x off of the top of the fraction. So it's going to be the cosine of x times the cosine of h minus 1 all over h. And then I'm also going to take the sine of x off of the top of this fraction, so minus the sine of x times the sine of h over h. Now what we want to keep in mind is that we're doing the limit as h approaches 0 of this whole thing. And because of that multiplication that's happening in there, we're going to be allowed to take the limit of those pieces separately. So this is going to be the limit of the cosine of x as h is approaching 0 times the limit of that fraction cosine of h minus 1 all over h as h is approaching 0. And then we're going to be subtracting the limit of the sine of x as h is approaching 0 times the limit of this other fraction sine of h over h as h is approaching 0. Now with this first piece where we're doing the limit of the cosine of x as h approaches 0, if we were to try to direct substitute h in there, this doesn't have any h's in it, so that 0 doesn't really affect anything. So this just stays as the cosine of x. And actually in the second piece here where we're doing this subtraction, same thing with this limit of the sine of x as h is approaching 0. There's no place for me to direct substitute that 0 in there, so this just stays as the sine of x. But we're going to have to numerically look at these other two pieces. There's no way for me to cancel out these h's in the denominator, so it's not actually safe for me to do the direct substitution with the h. So we're going to take a look at these on our calculator to help us numerically figure out each one of these limits. So in this first one, we're looking at the cosine of x minus 1 all being divided by x, and as we look at this graph, we're looking as x, or as h, is approaching 0. So as we approach 0 from each side, we can't actually plug in 0, that point doesn't exist, but as we approach from each side, that limit is approaching 0. And then for our second one, it's going to be the sine of x divided by x. So as I graph this out, and as we approach 0 from each side, Again, it's not safe to actually plug in 0, but as we approach 0 from each side, it looks like that limit is approaching 1. So this limit we said was 0, and this limit we said was 1. Well, if I take the cosine of x times 0, that just zeroes out of there. And then if I take negative sine of x times 1, that just becomes negative sine of x. So what we just established was that the derivative of a cosine of x function is negative sine of x. So now that we've established what the derivative of the cosine function is, now we can use it to differentiate things. So we're going to differentiate the equation y equals the cosine of x over 1 minus the sine of x. Now because it's a fraction, we're going to have to use our quotient rule. The numerator is going to be our u value. The denominator is our v value. So remember, the way the quotient rule works is we take our v value times the derivative of u minus our u value times the derivative of v, and this is all over v squared. So as I'm writing things out, I'm supposed to leave that denominator v value alone, so 1 minus the sine of x. Then I have to differentiate that u piece, which is the cosine of x. So if I do the derivative of that, we just said that was going to be negative sine of x, minus, now I leave the u numerator alone, so cosine of x, and then I multiply it by the derivative of the denominator. Well, if I differentiate 1, I just get 0, minus the derivative of the sine of x is the cosine of x, and this is all over that v value, so that denominator squared, so 1 minus the sine of x, all being squared. Now there is some simplifying that needs to happen in here. First thing I'm going to do is distribute this negative sine of x into this first set of parentheses. So I get negative sine of x plus sine squared of x. Now on the back end, I've got this negative cosine of x to distribute in. Well, negative cosine of x times 0 is just 0, so I'm not even going to put that in there. But then if I take negative cosine of x times negative cosine of x, that turns into positive cosine squared of x. And this is all over 1 minus the sine of x squared. Now on the back end of the numerator, we've actually got a trig identity that we can use if we remember sine squared of x plus cosine squared of x is equal to 1. So this whole piece on the back end just turns into 1. So we have negative sine of x plus 1 over 1 minus the sine of x, all being squared. Now what I notice is that the numerator and denominator have a lot of similarities, a positive 1 and a negative sign. I'm actually going to rearrange that numerator so that it says 1 minus the sine of x, and in the denominator we have 1 minus the sine of x, all being squared. So what I can do is cancel out that 1 minus the sine of x on top with one of those 1 minus the sine of x's on bottom. So now my numerator is just 1, and my denominator is just a singular copy of that 1 minus the sine of x. That's going to be it for this video. Thanks for watching.